Hello. So here it says if x is an integer. So if x is an integer and k is a number that is defined by this equation here, k equals this minus this, then which of the following statements must be true? Again, before we can begin to make any inference, what I have to do is, the way k has been defined, it looks a little cumbersome. That is, it looks as if k has been disguised. So I need to simplify this equation here before I begin to make any conclusion or draw any inference. So what I'm giving here is my k. So let me write my k here. So my k equals, so you have x negative 1, then you have x plus 2 and negative x negative 1 times x negative 2. Now this is what you have. Now what you'd observe here is x negative 1 is common, so I could bring x negative 1 out. So you have x negative 1 all into, so you're going to be left with x plus 2 minus, so you have x negative 2. This is what you're left with. So this is just going to give you, this is going to be your x negative 1 is still here. Then you have x plus 2 negative, now negative times x is negative x, negative times negative, that's going to be plus 2. So this is what you have. So now x negative x crosses out, so you're going to be left with 2 plus 2. So this is just going to give you 4 times x x negative 1. So in other words, we found our k to be 4 times x negative 1. And then we also know again that x is an integer. So now I'm going to draw inferences from these two statements and then use those inferences to be able to answer which of these options are true. Now from the first statement here, it says k is odd only when x is odd. So let me go to k. That's for the first one. I'm going to call this a. So it says when x is odd, k is odd. Is that true? Let's see. So let's say x is, since it says x is an odd number, so let's say x equals 3, and then we would now find k. So since x equals 3, so let's find k. So our k is just going to be 4 times, so our x is 3, so it's going to be 3 minus 1. So this is just going to be 4 times 3 minus 1, that is 2, and that's just going to give you, 8. So when x is odd, our k was odd. Our k is even, because 8 is an even number. So that implies that this is wrong. So let's go to the next one. It says k is odd only when x is even. So when x is even, so we are going to see if k is going to be odd. So let's choose, so this is going to be b. So let's choose our x to be an even number. So let's say x equals 2. And then we'll see what we would obtain for our k. So our k is just going to be, so using this formula again, so you have 4 times our x. Since our x now is 2, so negative 1. So this is 2 minus 1, that is 1, times 4, that is 4. So 4 is an even number. So x was even, but the k we obtained was also even. So that means, but here it says k is odd. So that implies that this statement here is false. So let's go to C. So what C says is when x is even, k is even. When x is even, it says k is even only when x is even. Now what you'd observe from this statement here is when x is odd, so this is when x is odd, x odd, we obtain even k, and when x is even, we obtained even k. So when x is both even and odd, we obtain even k. But here it says when x is even, it says k is even only when x is even. This is false. Why? Because k is even not only when x is even, but also when x is odd. So there shouldn't be an only here. So that implies that this statement here is false. And then also here it says k is even only when x is odd, which is also false, because k is not only even when x is odd, but also even when x is even, as we have seen in this part here. When x is even, when x is odd, k is even, and when x is even, k is also even. So that implies that the statement here is also false. So that tells us that none of the above options here is valid, and that tells us the solution to this problem has to be E. And that completes the problem. Thanks for watching.